This next one's a really cool demo. Literally cool.
Oh, yeah. So this is liquid nitrogen. And you can come look at it, but does anyone remember what nitrogen is? Cold. Well, now. Yeah. But nitrogen is actually in the air you're breathing, so it's part of the atmosphere. It's actually 70% of the atmosphere. And then the rest of it is basically oxygen. So here we have liquid nitrogen. And how do you make a gas a liquid? Cool it down? Exactly. This is negative 196 degrees. Celsius.
Oh.
It's very cold.
It's so cold that you can freeze just about, actually you can't freeze anything, including bananas. That's what we're going to do.
Alright, does anyone see this mist going on around here? Does anyone have a guess what that might be?
It's the nitrogen evaporating after it boils.
Alright, well it's good because it's boiling. This is definitely boiling. But what's coming out is the nitrogen. If it was, see this is white, and if it's 70% of the air is nitrogen, wouldn't the world be very white? So there's something else in the air, and it's something that we have a lot less of in the desert.
Water.
Yes. Water, like, the water is condensing on the side of this container because it's so cold. Just like when you blow on a window in the winter, you basically pull the water out of the air and put it onto this metal. It's everywhere now. Anyway, that's frozen.
That's probably good.
All right.
We didn't quite get it, did we?
Yeah, you can pass it around. It's not too cold. Just don't hold it for a long period. Just keep dropping it or tossing it or something. Potato. All right. So let's see. I need a volunteer.
I'm guessing it's me.
Okay.
I took this little forward. I know her. Christina here is going to get a beautiful flower. And she's going to look at this and say, is it a real flower? Is it nice and soft? Is it real?
Yeah.
All right, put it in there. Well, you have to have the 3 now. All right, we can take it out and hit it against that table.
Listen. Shh.
Beautiful flowers destroyed.
All right. Can anyone explain why the flower shattered and did not, like, bend or anything? Do you want to try, anyone? Well, if you remember, when things get colder, they become more brittle. And if you remember brittle when you were learning about metals, brittle is how easily they fracture instead of bend. So at cold temperatures, almost everything becomes more brittle and less ductile.
Also happens with rubber. So you can see this racquetball, super bouncy, but when we throw it in liquid nitrogen, you can see what happens. Anyone know any uses for nitrogen or liquid nitrogen in everyday life?
What do we use it for? Why would we want something that cold?
Ice cream.
Different nuts are made using liquid nitrogen.
We actually make it in science club.
Oh yeah, it's real safe.
What else?
Something medical.
Sterilization.
Sterilization is usually very hot. Things. Have you ever had a wart or something you need to get rid of? Yeah. When they burn it off, it's actually very cold. Cold temperatures do less damage to the skin around it.
Kills all.
Also, instead of dying, you could have them freeze your body cryogenically, and you could live forever in a frozen state. And then maybe someday, when we figured out how to make you live forever, we could thaw you out, and then you would live forever. Supposedly, Ted Williams' brain is on ice somewhere.
Ready? So once I catch,
Oh my god.
and you can keep that if you grab it.
Hand like a hot potato or a cold racquetball if you...
One more fight on it. Pass that on. So what happened to that? Why did that shatter and not bounce like the other one?
Because it's frozen.
Because it's frozen, yes. Just like when you have water. Alright guys, watch this. This is pretty awesome.
Alright.
Do you want
Really cool, huh?
That's the air balloon that's going in there right now.
Yeah, blue filled with air.
Nothing fancy. You can hear it crackling.
Alright, now look at it.
Now watch what happens as this warms up. Does anyone want to explain what's happening here? You want to try?
She got cooler and
Exactly. If you remember your gas laws, as temperature goes down, volume goes down. As temperature goes up, volume goes up. As this warms up from negative 200 degrees Celsius, it's going to expand a lot.
We have one more. This is a balloon that is filled with water.
You guys need more nitrogen, or are you okay?
We should be fine. Think about that.
Oh, try to put your hand in it.
You can. Just flick it out. You're okay.
Alright, so you may think that you can't actually touch that, else you freeze your body parts, but you can actually throw your hand in it. That's kind of cool.
Oh, be braver. You're okay. Put it in, grab a little bit, flick it out on the floor. There you go.
Yeah, it boils so fast that it really doesn't come in contact with your hand. Now, if I left it in there for like maybe 15 seconds, I would be able to take my finger and smash it open like that.
Banana.
Thanks, but
What's the, anybody know, this is negative 196. What's the coldest temperature that you can actually achieve? Yeah.
Negative 273.
And what do we call that temperature? David? Absolute zero. Does anybody know on a molecular level what's going on at absolute zero?
No.
Someone not named David? Yes.
It's so cold that nothing moves.
Yeah, the molecules themselves stop vibrating. And so you pretty much, we never get there. We can get really close, like really close, within 1/1,000,000th of a degree, but we cannot get there. All right. Let's go back and see what's happened here to the water balloon.
here's a little more. Get this one really
Alright. I don't know if you all heard this, but he pointed out earlier this is boiling. Just like when water boils at
212
212?
Fahrenheit.
Never remember. 100 degrees Celsius. Easy to remember. This is boiling at room temperature. Quite violently, actually.
Yes.
So we're going to take this out, and we're going to show you all what happens.
Okay, so now you're going to turn it over, so it'll probably this one spot that has to be frozen. Yeah, it's really, really frozen. Do you want to stop it?
Yeah, balloon snap.
That's cold.
Really?
Yeah. This is not.
You got no opening in the...
No.
Here, try
I mean,
this side.
We could try the
There you
water.
go.
There.
Incoming.
Hey guys. Does everyone see water squirting out? Do you realize that means water's inside? Why might water still be inside of this?
Oh boy.
It's a pleasant sound.
Yep.
Ah, that's really cool.
Oh, that's
Yeah.
Hey, you're going to need the gloves to handle that. That's going to be smoking cold.
All right.
Fucking cold. Yeah.
Alright, go show them. Here, I'll just grab it.
That's good. You don't have to get all the way off.
Alright, does everyone see it? But you might notice for here that the inside's actually still water. So what does this resemble to you? Does it look like anything? An egg, yes. Why might that happen? The inside's inflated. Exactly, just like a pond.
Very good.
That's why the ponds never freeze. You're the first one to get that. Getting smarter. Alright, so yes. This would be the best example of an egg because that froze so quickly the ice became an insulating layer and the inside was not able to freeze.
Very good. Oh, show them the one last thing.
Oh, yeah. Go for it.
All right. Well,
Yes.
Let a few of them blow in it first.
Oh, yeah.
go ahead and
Don't be bashful.
to it.
Get close. God, get closer. There you go. Of course, you have a lot of moisture in your breath, and that's what you're seeing there, is it condensing.
You might want to get any open-toed shoes off the ground really fast, but
But you can touch this.
yeah. Go ahead and you can touch the little droplet stuff.
The little droplets are oxygen, which freezes at a higher level.
Excellent, guys. Let's give them a round of applause.